Welcome to the class, my dear students. So far, we have done the partial differentiation of two variables and three variables. Also, we did the partial differentiation with of second order of two variables and how to verify the mixed partial derivatives are equal. That means dou square f by dou x dou y, is it equal to dou square f by dou y dou x is or not. Is the checking part is also done in the previous lectures. Now we are going to see the application of the partial derivatives with respect to the variables x and y when the function a is a function of two variables x and y. So this is called as the total differential and the approximations. Suppose if you are given a continuous function, of course, and if dx is and dy represent the errors of the changes in x and y respectively, then the total derivative is given by, that means what actually, if there is a function with two variables, let us have an example of a rectangular area, suppose. And if there is a change, now the area is of, the example let us take, area is a function of two variables, length comma breadth, correct? Now if there is a change in length, then we write it as dl. If there is a change in the breadth, then we write it as dv. Now the change or the errors in dl comma db, or both of them, will occur. Now it will affect the change in the area, and that is given by dA. Okay, so the total change in the area is given by, is corrected with the change in the length and breadth. So that's why we call it as a total derivative, or the total change in the area is given by the change of the area with respect to L with the change in dl, along with the rate of change in area with respect to the breadth b times of the change in the breadth b dv. So then we say that it is the total derivative. So what is meant by the total change means, the meaning here it is giving you in such a way that if there is a change in one variable, the partial derivative of that particular variable multiplied by the change in that variable. Similarly, the partial derivative of that function with respect to the another variable and the change in the other variable. If you add both of them, we get the total change in the function. So this is the easiest way to find out the total change in the function, or total error in the function, or the total differential in the function. We call this like this. Now let us have, there are some types of derivatives we have, errors we have, errors or approximations we can say. The absolute error or the absolute change in the function f of x comma y is given by, suppose due to this absolute change has happened due to change dx in x and change dy in y. Then whatever we got the total derivative df, we just find out the absolute value of that gives you the absolute error. And then coming to the relative error. Relative error is what? The total derivative, what is the absolute error by the function f, that gives you the relative error. And then the percentage error is what? This relative error, whatever you have got, multiplied by 100, that gives you the percentage error. So let us just find out some examples, let us say. So let us look at these examples. If I say that there is a relative error, the relative error is given by, let us say 0.5, and the relative error in the function, and the function value is something like f5, it is 5. Then what is df is asked, suppose. Then how to find out? What we know about the relative error is given by modulus of df by f. That is what the relative error. So what is given relative error as 0.5, and df is, we don't know, by 5. So what is the value of the total error? df is given by 5 times of 0.5, which is 2.5. So this is what the way to find out the total error in the function if the relative error is given. In the other way, vice versa, if the function f value is given and to find, and relative error is also given, find df, or the percentage error is given, find df, or something like that also, you can think about the functions by just interchanging the formula. So let us see some examples how to find out the total error. Find the total derivative. Find the total derivative or the total error. Total derivative of the function f. What is the function f given by x cube plus 2xy? So this is the function f. So let us now see what is the solution. So f is a function of x and y, correct? So first we are going to find out what is dou f by dou x. Dou f by dou x is given by derivative of x cube 3x square. Derivative of 2xy is 2y. Okay. Similarly, find out dou f by dou y. That means derivative of f with respect to y. X cube derivative is 0 and derivative of 2xy becomes 2x. Now we need the total derivative. So what is the change? What is the formula for total derivative? Is given by df is given by dou f by dou x dx plus dou f by dou y dy. So this is what the total derivative formula. So we know what is dou f by dou x is given by 3x square plus 2y times of the error in x, that is dx, plus 2x times of df, that dy it is actually is dy. Okay, that is what the total derivative. Suppose in the same problem it was given that if the x values are given as, let us say some x is 1 and y is equal to 2, and the rate of change, the change in x is, let us say some 0.01, and the change in y is called, let us say 0.02 something, then what is the total derivative? Just plug these values in the total derivative f. That means 3x square is 3 into 1 plus 2 into y is 4, dx is 0.01 plus 2 times of x is 2 and dy is 0.02. So what is this giving you? 7 times of 0.01 is 0.07. 2 times of 0.02 gives you 0.04. So what is this value? 0.11. 0.11 is the total change in the function when there is a change in x as 0.01, y as 0.02. So like this you can find out the total derivative of a function when a function is of two variables. Okay.